Alright, so we have a house and we have 150 feet of wood. We want to maximize the volume of this house. The roof is created using equilateral triangles, 3 equilateral triangles in fact, and the bottom is a square on one side, and then it's a rectangular prism with a square side. So we want to maximize the volume. The volume is going to be length times width times height for the bottom, plus square root of 3 over 4 x squared. That gives me the area of the triangle times y, the length. So area of any prism is area of the base times the height. Area of the base times the height. Okay, unfortunately the volume is in terms of 2 variables, so we're going to have to use the wood that we have to get rid of one of those variables. So the 150 feet of wood, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 x's plus 1, 2, 3, 4, 5 y's. So I'm going to solve this for y. 5y equals 150 minus 15x. Y is equal to 30 minus 3x. And I'm going to plug that in for each y into my volume equation. Okay, so that's going to give me volume equals x squared times 30 minus 3x plus square root of 3 over 4 x squared times 30 minus 3x. Alright, and to make my life easier, I'm going to factor out everything that's in common. So okay, the reason I'm doing this is because now this piece right here is just a constant, and when I distribute this piece over here, I just have a constant times a function, which is a much easier derivative to take. So v prime, I'm just going to leave my constant alone. It's going to be 60x minus 9x squared. I could use product rule here. It would be first times the derivative of the second, which is 0, plus the second times the derivative of the first. So this is fine. Now, we're trying to maximize, so I'm going to set it equal to 0. I'm only concerned about the second piece. I'm going to factor the 3x out. I get 20x minus, nope. I get 20 minus 3x. And then finally, that occurs when x is 0 or when x is 20 thirds. So I'm going to, okay, it doesn't make sense to have an x less than 0. Okay, and the maximum value that x could be technically would be if there's no y, then x could be 10. So that's the largest x could be is 10. Nothing over 10 makes sense. Alright, so I'm going to test some values. 20 thirds is 6.666. So a value I could test would be 1. If I plug 1 into my derivative, I get a positive number. If I plug a 9 into my derivative. I get 60 times 9 minus 9 times 81, so it's negative. And we have a maximum. So when x is 20 thirds, and the other x is 20 thirds, and the y, let's go back to the top, y is equal to 30 minus 3x. So 30 minus 3x is going to be 30 minus 20, which is 10. So 6 2/3 feet by 6 2/3 feet by 10 feet long, which is essentially how we built our parade float. Pretty cool. And so here's all the work.